This episode finally solves the mystery of Pokemon evolution. That's it. No Yu-Gi-Oh! Joke, no nothing. If you want to learn the truth about what's really happening with Pokemon Evolve and how it applies to us, well then, this is the video for you. Plain and simple. Roll intro. Hello, Internet! Welcome to Game Theory, the self-proclaimed Garbodor of the Internet. With the release of Pokemon Let's Go Pikachu and Let's Go Eevee, it seemed like the fitting time to take a look at one of the most adorable Pokemon ever created. No, not Pikachu, jeez, I think I get something else every time. We're talking about Eevee, who's unique within the Pokemon universe for being the first Pokemon to have branched evolution, i.e. the ability to evolve into one of several Pokemon, starting with 3 options in Generation 1, Jolteon, Flareon, Vaporeon, and since Gen 1 the list of possible evolutions is just cut ridiculous. You can now evolve into 8 possible Pokemon ranging from alien cute to kawaii cute to eco-friendly cute. Since then there have been other Pokemon who've gotten access to branched evolution, but to this day, Eevee is still king. And so I started to research Eevee's unique evolutionary abilities, and then pieces started to fit together, and then more pieces. More. Until finally the entire mystery of Pokemon evolution lay solved before my eyes. That's right, Eevee is the key that solves what Pokemon evolution actually is. For years we've made jokes of that's not how evolution works, and clearly it's not. But we've never been able to put a label on what is really going on, at least until today. Today we solve the riddle that is Pokemon evolution once and for all. It all starts. Oh gosh. According to Eevee's Pokedex entry in Diamond and Pearl, Eevee is a rare Pokemon that adapts to harsh environments by taking on different evolutionary forms. If you squint at this explanation, it kind of seems to line up with the principles of evolution that were taught in school, where over time living organisms change their looks, traits, and abilities to adapt to their environment in Darwinian survival of the fittest. But the problem is that in Darwin's definition, this is happening over hundreds of generations. What's happening to Eevee is happening instantaneously when I shove a colored rock in its face. What we see happening in Pokemon would be like if I took a turkey in the North Pole, stuck it next to an iceberg, and suddenly it evolved into a penguin. While admittedly that would be really cool, and judging by how desperate Game Freak seems to be for new Pokemon ideas sometimes, it wouldn't really surprise me for a Penguin or Turtwig to be in Gen 8. It's just not the way things happen in nature. So evolution alone isn't explaining how Eevee's physical changes are happening. But believe it or not, there is, in fact, scientific explanation for EV, which is good because I like EV and we already read it. It's called epigenetics. Epigenetics is something that you don't usually get into unless you're majoring in this stuff in college. So all you younger viewers, get ready to blow your teacher's minds when they drop this knowledge bomb in the middle of your lesson about Punnett squares. Those are so like 4 years ago on this show. So what is epigenetics? At its core, it's essentially the phenomenon by which animals are born with one set of genes, but potentially have parts of their DNA that are locked at birth and then later be unlocked by certain things happening in the environment. If that sounds weird, think of it this way. You have a ton of DNA in your body, 2.9 billion base pairs, but not all that DNA is working all at the same time. Without getting into the nitty-gritty genetics, your cells have specialized proteins that turn off and on different genes throughout the course of your lifetime. When you're a kid, you have a ton of genes that turn on to do things like grow your bones, build your brain cells, and create hormones that make you fall in love with literally every creature that you pass in the school hallway. Later in your life, though, some of those genes get locked back up. When that happens, maybe your metabolism starts slowing down. Stop producing color for your hair and it turns gray. As you get older, you have all the same genes that you started with on the day you were born, but how you look is depending on which ones are turned on and off. So epigenetics. Right now, my baby Oliver has blonde hair, but Steph and I have brown hair. So should I be worried about Steph's relationship with the milkman? Steph cheating on me? Of course not. I don't think so. Steph, are you cheating on me? Oh yeah. No, what's really going on here is that right now, most of the genes in Oliver's system that produce melanin, which turns your hair brown, are turned off. Like, way off. Just like I had when I was a kid. When he gets older, those genes get activated, and his hair will turn brown just like ours. His physical traits will change as his genes turn on and off. Now, with animals, what epigenetic researchers have discovered is that some animals will be born with one set of genes, but potentially have parts of their DNA that can be unlocked by certain triggers in their environment. A great example of this are honeybees. Yeah, I know, I just dedicated an entire episode to bee talk as it relates to bee jets. Maybe I'm just going through bee withdrawal. I don't know. Bees are fascinating creatures, and in this case, they are the perfect bee example. So, like I covered back in that episode, female bee larvae can grow into either a queen bee or a worker bee. What makes the difference here is the food that they're given at birth. Bees get royal jelly from a queen, while everyone else becomes a worker. So in this case, royal jelly is basically the evolutionary stone for bees, determining what form the larval bee evolves into. It even changes to be physically fair in their adult stage. Queen bees and worker bees look way different, but in their larval stages, they're practically identical. It's exactly like two different species that wind up with two different appearances, despite starting with the same looking bees. Queen and worker bees did start off as genetically different, but the differences in their environment, royal jelly, or lack thereof, led to wildly different gene expressions. And these aren't the only place in nature where this happens. Another bee-like example happens to be a bee mouse, which has a gene which changes the fur of its coat. These two mice are genetically very similar at birth, but due to differences in nutrition, they have very different gene expressions. With one having a gene expression that causes it to become obese and have lighter fur. Same DNA sequence, different phenotypes, all due to environmental factors. In humans, it isn't just hair color either. Case in point, diabetes, specifically type 2 diabetes. We're often told two things about diabetes that seem to directly conflict with each other. First, that diabetes is a genetic disease. If your parents and grandparents had it, well, it's more likely to be passed down to you. But also, second, that poor diet and lack of exercise can be a cause of diabetes. So then, which is it? Is it a genetic thing that you're born with, or is it a condition that you develop from eating one too many solo for monster challenges at Ben & Jerry's? That is a dangerous prospect, by the way. He's not trying to do a solo for monster. The answer is it's both. You might inherit a genetic potential for diabetes that's part of the DNA pool that you're born with, but that diabetes may only get unlocked if you have a bad diet. And if you maintain a good diet, well, you might never have to suffer the diabetes that was encoded into your genes, as though the genes remain turned off. On the other hand, someone without a genetic predisposition to diabetes might never get it, no matter how many Big Macs they eat on the way. And this kind of epigenetics perfectly lines up with what we know about EV. In order to become a Vaporeon, for example, a Pokemon not only needs to be exposed to a specific environmental factor, this weight or certain characteristics, but you'll still always remain the same species. watch, it won't lay a Jolteon egg, it lays this Eevee egg. While Eevee and Jolteon might have different entries in the Pokedex, in biological terms, they appear to be the exact same species. The DNA sequence between the Eevee and the Jolteon has stayed the same. The only thing that's changed is what parts of the DNA sequence have gotten turned on. No matter how Eevee evolves, when it comes time to reproduce, it's always going to lay Eevee eggs. Sylveons don't lay Sylveon eggs, Flareons don't lay Flareon eggs. They don't pass their phenotypic traits on to their offspring. But what they do pass on is the genetic potential to express those phenotypic traits. Sure, there are a few exceptions to this, like how Rosalia can give birth to either another Rosalia or the tiny Badoo based on whether it's a rose incense. But this also ties in with another part of that genetic theory, which is natal conditions of the mother during pregnancy, and how it can affect their offspring. You know how pregnant women aren't allowed to do stuff like smoke or drink alcohol? Well, it's because those substances change the environment for the developing baby, just like it changed the environment for Eevee or Bee. This one is just happening before the baby is actually born. In milk